in this demo, we'll be estimating best project cost and revenue in under 10 minutes. So let's see how we can do that using Storlytics. All right, so first thing you do, obviously open up Storlytics, just input the project name. All right, and the first thing you're going to see under the battery system modeler is the general tab. In here, we'll just start putting in project details. Let's assume it's a 10-year project life. Deployment strategy here is say user defined. Could pick augmentation, but let's keep on user defined. Auxiliary load source. For this example, we'll just be assuming a separate source for auxiliary load. And we'll be assuming it is a transmission tied project with a GSU. Yes, we'll definitely want to deduce financial results under simulation options here. Also want to take into account BESS degradation and also take into account enclosure temperature regulation, which is obviously the biggest chunk of auxiliary load in any BESS project. Under interval data here, we'll switch from time series to standard cycle. And here we'll just put in the project rated power. Let's just say 100 megawatts, 4 hour, and 1 cycle a day. For the meteorological profile, which has the temperature information and ambient temperature information of the project location, we'll be selecting New York, for example. So let's just assume the project's in New York. And what this does is it helps the auxiliary load estimation be very accurate because it takes the typical ambient temperature profile for that specific location. Okay. So under the equipment tab, the first thing we want to specify is the battery model. So we can assume here just a generic LFP. So let's just assume a generic LFP 306 amp hour battery model. Under the inverter model, let's just assume an SMA inverter. And under the enclosure model, let's assume a generic enclosure that's air-cooled and made out of steel. So here, then we can go to automatically sizing this project. You put in the required information under general, turbo tab, and equipment, and now we can just have Storlytics automatically deduce project size. So once you click auto size project, this window will come up. Just click OK. It'll confirm that you want to design the system based on at 10 years using an overbuild strategy. So then here, just click yes. And then auto sizing will commence. So it should take about 30 seconds or so to complete auto sizing. Okay, now we can see that the system has been sized to about 119 megawatts in inverter capacity. And for the energy capacity, about 557 megawatt hours at the battery terminals. So you can see everything under system specs has been filled out. And here, the number of modules per racks, number of racks per inverter, and number of inverters, and also the losses. And in addition to parameters under operational limits have been set to what is typical for BESS project operation. So now we can head on over to the financial tab and select our financial assumptions. So here, you can select a generic lithium LFP financial model. And obviously, this model can be changed by the user as needed, any of the details within it. And then we can go to here. So we'll keep deduced cost on and keep deduced revenue on. So for cost, let's include everything here. And under revenue, let's keep it as a tolling agreement. And let's just say it's going to be effective in 2028. That's when the project is going to be deployed. And contract term, let's just put 10 years, similar to the project life. And now we're ready to run the simulation. So let's click run here. All right, now we can see that the simulation has completed. So now we can generate the report to look at our financial results, in addition to other results about the simulation. All right. So here, the report starts off with all the inputs we provided. Then the system adequacy, we won't go over that. Leave that at a later time. Auxiliary load consumption. And here we'll start reviewing the results. So here you can see that the system has been automatically sized to last for 10 years, as we specified in our inputs. So as we said, it started with a 557 megawatt hour capacity, and it shows you here how the BESS system is degrading over time. Here also, point of interconnect energy capacity over the project lifetime. We can see that we're maintaining the required energy capacity at the POI. So it shows you the losses, but here is where the financial results start on page 10 of the simulation report. All right, so the first graph we have here is the net present value of the project. So we can see here it's at about $155 million in net present value. And that takes into account the DC block capital cost, PCS cost, GSU and breakers, balance of plant, and net present value of energy losses, in addition to net present value of state of health guarantees. And obviously, these are all values that could be adjusted within the financial model we talked about over here. All right. All right, so here we can also review the OPEX details over the project lifetime. How much are we spending each year on energy losses? How much are we spending on the state of health guarantee? So you can see here that the state of health guarantee starts from year 4, or really the end of year 3. That's because within the financial model, the assumption is that you're getting a warranty for the first 3 years. So you're not paying for a state of health guarantee or any type of energy availability guarantee. Okay, so now we can go on to page 12 to look at the revenue results. So as we can see here, we have the details of the revenue over the 10-year project life. And because it is a tolling agreement, that revenue is constant. We did not simulate any type of penalties, so energy capacity liquidated damages, RTE liquidated damages, or availability liquidated damages. So it's basically a constant revenue here, but we can obviously change that. And now here on page 13, you can see both revenue and cost of the project over a cash flow diagram. So you see here in year 0, that's the project cost in the beginning of the project, and then over the years, revenue minus cost. You can also see depreciation because we're accounting for depreciation in our financial model. And here you can see a discounted cumulative cash flow over the project lifetime. All right, I hope this was helpful. If you have any questions, definitely reach out to us at accounts@storlytics.net. Thank you so much for watching, and we'll see you on the next one.